Electricity consumption optimization using K-image clustering algorithm. 현황차 2017 710116. Advisor 동료신 President. Co-advisor Dr. Nam Mohammad Qureshi, Sangwon University, South Korea. Outline. Introduction. Second, related work. Third, proposed approach. Analysis of electricity consumption at home through a score perspective. Analysis of electricity consumption at home using K-image clustering algorithm. Evaluation. Electricity consumption at home analysis. K-image clustering analysis. Conclusion and references. Introduction. Electricity consumption. Power grid. In the power grid, we measure the consumption through sensors. First, industrial consumption. Housing consumption. Factories consumption. Housing consumption. Front-end consumer end. Back-end electrical company end. Introduction continues. Back-end company end. Dataset for consumption from UCR. So many techniques that solve the optimization problem of electricity, but none of them focus on housing electricity optimization. Reducing the cost, factors of overcharge, and prediction are not available. Introduction continues. Solution. K-image algorithm. Why choose K-image cluster? Predict the answer from the dataset. No any answer is available in terms of K-image. Why predict the answers? No clear result. In this paper, electricity usage of home is analyzed through K-image clustering algorithm for obtaining the optimal home usage. Electricity usage of home is 3A is analyzed through the K-image clustering algorithm for obtaining the optimal home usage. Electricity data point. The Clarence-Garbage index, Davis Borden index, and Silver score dictate the optimal number of clusters in the K-image algorithm and present application scenario of machine learning algorithm. 3B is reducing the A per 1 dataset and result the same result. The proposed approach delivers us efficient and meaning prediction result never obtained before. Related work, machine learning, a way to run machine with dataset values, reference 1. Several ways such as reference 2, 3, and 4. K-image clustering, one of the methods for machine learning algorithm under the unsupervised learning category. Reference 5. It is a main task of exploratory data mining and a common technique for statistical analysis used in many fields. Reference 6, 7, and 8. Community feasibility assessment. Cluster analysis is not one specific algorithm. What constitutes a cluster and how to efficiently find them? Popular notion of clusters include groups with small distances between cluster members, dense areas of data spaces. Reference 9, 10, and 11. Reference work, related work, continuous. Classification is a process related to categorization, the process in which ideas and objects are recognized, differentiated, and understood. Reference 12, 13, and 14. Supervised learning. Supervised learning is a machine learning task of learning a function that maps an input to an output basis on example, input-output pairs. It infers a function from level training data consisting of a set of training examples. 15, 16, and 17. Unsupervised learning. Too many approaches to solve the problem, such as in clustering, K-image, mixture models, DB-scan, optics algorithm. 18 and 19 and 20. Index. From the unsupervised learning needs how to efficiently find them. Popular notion of clusters include groups with small distances between cluster members, dense areas of data spaces, such as the Clarence-Garbage index, Silver score, Davis Borden index, number 21. Related work continues. Scikit-learn, one of the machine learning library from the 2007 till 2019, continuously update the version of the library. Reference 12 to 22. Machine learning repository overview from the University of California, Irvine Machine Learning Repository, and the individual household electric power consumption dataset. You can find it from the website. Reference 23. Dataset parameters. First, date informate day, month, and year. Second, time informate hour, minutes, and second. Third, global active power. House global minute average active power in kilowatt. Fourth, global reactive power. House global minute average reactive power in kilowatt. Voltage. Minute average voltage in volt. Global intensity. Household global minute average current intensity in ampere. Submetering 1, submetering 2, submetering 3. Definition of dataset. Household power consumption from dataset from the UC California Urban Machine Learning Dataset Repository, reference A, and then use it. This data is via delimiter is divided. Global active power, global reactive power, voltage, global intensity is divided. Global active power and global reactive power, the XY axis experimented. Proposed approach A. Analysis of electricity consumption at home through a serial score perspective. Serial score. Serial score is an easy way to in data each data cluster in data's definition. On I, each data is a clustered inner and data's definition. Pi serial score Si is equal to calculate that Si equal max Ai Pi minus Ai. From this calculate, Si is equal to the function minus 1 Si 1. Si is close to 1 is the data, I is correct cluster to each thing. Close to minus 1 cannot distribute cluster. Is distributed. From this machine using the machine learning library, scikit-learn in the household power consumption clustering. Reference 23, 24, and 25. Analysis of electricity consumption at home through a serial score perspective continues. Current calorie index. How to be relative clustering in a way is current calorie index, Davis burden index, Dunn index, serial score. In this paper, evaluate via current calorie index and the serial score evaluated. From the current cluster, current calorie index, I, the cluster is distributed average, and the cluster distributed ratio will give it to you Sk, Tr, Wk, Pk, K minus 1, and minus K. For this, Pk is distributed matrix from each group. Wk is cluster distributed defined. Reference 26, 27, and 28. Wk sigma K, Q1 K. X minus Q, X minus Q T, Bk sigma Q, and Qc Q minus C, Q minus C, and T. Analysis of electricity consumption at home through a serial score perspective continues. Davis burden index. If the ground truth labels are not known, Davis burden is sklearn matrix Davis burden. As Rij Si plus Sj, Dij, then the Davis burden index is defined as dv1k. Sigma I, 1k max I not j. Rij, the 0 is the lowest score as possible. Score values close to 0 indicate a bare partition. But the problem is in this algorithm do not attach it in the scikit-learn library and only explain it in the document page but cannot explain it easily. Reference 29 and 13 and 31. Proposed approach B. Analysis of electricity consumption at home using k-means clustering algorithm. Reducing the dataset. A for 1 dataset for this archive contains 20,000, 20,000, 20,007, 2 million, 75,259 measurements gathered in house located in Secos, 7 kilometers of Paris, France, between December 26 and November 2010, 47 months. Notes. This is a fit the same result, labeled data for machine learning, already cleared cleansing for the dataset. Evaluation, declaration, and resources. System PC configuration software. A. First paper execution snapshot. B. Second paper execution snapshot. Analysis A. K equals 7 result for the experiment. From k-means algorithm, calculate proper cluster thing is very important. From the data estimated serial score, the result is k equals 7. Each cluster centroid and data prices serial score are 0.799 is the optimal score. From the former current calorie index, results are 560.3999 is optimal result. Using this k-means algorithm, the fact is figure. Analysis continues, but the problem is in this algorithm, do not attach it in the scikit-learn library and only explain it in the document page but cannot explain it easily. Analysis B. Figure serial score according to change of cluster number. Figure A for 1 dataset serial score according to change of cluster number. From k-means algorithm, calculate the proper cluster thing is very important. From the data estimated serial score, the result is k equals 7. Each cluster centroid and data prices, the serial score is 0.799 is the optimal score. Even if the dataset is so small, but the A for 1 dataset k equals 7, each cluster centroid and data prices, serial score is 0.810 is the optimal score. From this k-means algorithm, cluster 7, all the datasets A for 1 dataset, each growth centroid and each centroid distance will be an optimal value. From this result, the dataset decreases, but the k-means clustering class vector spaces. Its optimal cluster is the same situation with before. Original dataset household power consumption rate via clustering. This is the evaluation for the execution A execution snapshot. K equals second snapshot and third and fourth and fifth, sixth, seventh, eighth, ninth, and tenth result. K equals seventh result is the optimal result for this experiment. Evaluation B execution snapshot. A for one dataset for K equal 1, A for one dataset K equal 2, A for one dataset K equals 3, and fourth and fifth and sixth, seventh and eighth and ninth and tenth and 11th. And this is also the A for one dataset K equals 7 is optimal result for this experiment. Using the index and the recognize the optimal result for the experiment. Software and workstation environment. PC performance. Software Anaconda 3 plus PyCharm 3. Web software Windows 10 Professional. RAM 16GB. Processor i7 6600U. CPU 2.60 GHz. Hard disk 420GB SSD. PC compilation software dataset used turbine machine learning dataset. Scikit-learn, Anaconda 3, and PyCharm. Open source personally can easily follow it, and because using BSD license to real world don't have difficulties to do that. Conclusion: household power consumption via K-means clustering use a library which is Scikit-learn, Anaconda 3 open source personally can easily follow it, and because using BSD license to real world don't have difficulties to do that. Not only the K-means algorithm, PCA algorithm, but also SVM algorithm, etc. Other machine learning algorithms cluster can also do it. From this result, in real life household power consumptions, diverse analytics, an electric transformer transmission power can management period can estimate it, and its data using electric consumption, it can be used for forest extension, regional to regional demand forecasting. Maintenance of power plant and facilities can do it. In the gas company, Seoul Gas, Google TensorFlow meter of second, 2017, can estimate via K-means algorithms and also can estimate about the gas consumption rate to via K-means clustering and index. Paris paper, Hyunong and now Frankish and Dong-Yoshin. Comparative analysis of electricity consumption at home through a select perspective. ICT 2019, South Korea. 2019, Sungkyun University, Korea. Hyunong and now Frankish, Fresh and Dong-Yoshin. Analysis of electricity consumption at home using the K-means clustering algorithm. ICT 2019 South Korea, 2019, Human News Korea. This acknowledgement. Advisor, Dr. Dong Yun-shin, President of Sungkyun University, currently May 14, 2019. Co-advisor, Dr. Muhammad Fakih Karish, Assistant Professor. First joined the SKQ Mobile Computing Laboratory, Professor Hyung-yun and SKQ Fellow, and advising for pre-defense. Dr. Robotics External Professor. First joined OpenLab, Dr. Chun Sung-nam. And POSCO ENC Hyun-seok Choi and Deputy Manager, Cooperative Partner and the LG Electronics AG CNS and NG Plus. And the Menhono and MD PhD. Google TensorFlow Meetup, second, 2019 conference. And from Seoul Gas. That is motivated from the conference. OpenLab member, currently May 14 and 2019. Dr. Giyan Choi and Muhammad Hamza and Janet and then Woo Kim and So Chung. Acknowledgement. LG Electronics support the tuition and academic support, and the LG CNS and LG Electronics and LG U Plus also invited the conferences and then suggest a good knowledge for the research. And then POSCO ENC support the transportation support, and Google AI also there's some motivation from the conferences. TensorFlow Meetup 2019. Korean AI support when I participate in the conference and they suggest some about the Monicom services and participate in the conference. When I take a class at the safe and security and relaxation time, some medical system release the stress and volunteer works. Sometimes eye center and then vision management. Youngji Hospital Split Support. References. This is all of the slides references. End of slide and then Q&A.